we have a block of mass that is 10 kilograms, and it's being pulled along a horizontal floor at constant velocity by a horizontal pulling force P. So I know this is P, and I know this is 10 kilograms. The coefficient of kinetic friction between the block and the floor is 0.4, and the block is pulled a total distance of 8 meters along the floor. Okay, so I see the pulling force, but how many other forces do we have? 3 other forces. Okay, what's one of them?
Gravity.
All right, the weight force, sure. So we have a weight force down. So how much is that going to be? 100 newtons. All right, what's the next one? Normal force. How much is that? Why? So we have no forces working at an angle here. Okay, no additional forces. And because of that, all right, we know it's not floating in the air, it's not falling through the ground, so we know that that y component of force is in equilibrium, so the normal force has to be 100 newtons. Okay, and what's our last force? Friction. What do we know about friction? We do know that. We know all those things. What about if I'm going to draw the diagram? What else do we know?
That's opposite direction.
Is it going to be less than P? Or more than P?
Because it moves.
It does move. Oh, but it's at constant velocity, so it's going to be the same size as our pulling force. Okay, so the same size of our pulling force. So we want to know what the pulling force is, P, and we know friction is the same size. So let's figure out our friction. So I heard somebody shout out before, friction is our coefficient of friction, of kinetic friction, because we're going to be in motion, times the normal force. So that's going to be 0.4 times 100 newtons. And so what is our friction force? 40 newtons. Okay. Now, like you guys said, we know that the sum of the forces in the x direction have to equal 0 because of constant velocity. And therefore, the pulling force has to equal the friction force. And what does that equal to? 40 newtons. Okay, so now we want to talk about the work. All right. Now, we want to know the work done by force P. And we learned today that the work is force times displacement times the cosine of theta. All right. Now, what direction is the pulling force? To the right. What direction is my displacement? Also to the right. Therefore, what is theta? 0 degrees. And what again is cosine of 0 degrees? 1. So work is really, in this case, just force times distance. And what force are we looking at in particular? Our pulling force. And our pulling force is 40 newtons. Our distance is 8 meters. And therefore, the work of the pulling force is 320 joules. All right, remember work is just an energy, transfer of energy. So our units are going to be in joules. So the next thing we want is the work done by friction. Okay, so we can look at this a couple of ways. One of the ways that we can look at it is using the equation. This time friction is this way, and our displacement is to the right, and therefore what is theta? Theta is 180 degrees, so that means work equals negative force times distance. But what is the force we are particularly looking at? Friction, so it's just negative friction force times displacement, so negative 40 newtons times 8 meters, and that's going to be negative 320 joules. All right, 320 joules. What do you guys notice about the work done by friction versus the work done by the pulling force? Very equal in opposite directions. Okay. Now, why would the work be equal? What's happening in this process, in this problem that it would be equal and opposite? That constant velocity is making that work in the x direction equal and opposite. All right. Well, let's take a look at the other two things we have going on. We have our gravitational force. So our weight force is coming down. But our displacement force is, or our displacement, not force, just the displacement is to the right. And therefore, what is the angle between them? 90 degrees. And what is the cosine of 90 degrees? And so if I have work equals FD cosine theta, obviously the work here must be 0 joules. Okay, so no work is being done by the gravity force to move the box to the right. All right, there's no energy transfer to the right done by gravity that's working downward. And then we have our normal force, and that's upward, but our box is moving to the right, and therefore, what is the work done by the normal force? Also 0. Okay, so the total work done on the block, if you were looking for the net work, yes, we could add up all the work in the x direction, the y direction, and take a look at that. However, it turns out that the net work is actually the net force times the displacement times the cosine of theta. Okay, and in this case, what is our net work, or net force, I mean? It's 0. Okay, so 0 newtons. Therefore, our net work must be 0 joules.